we are looking at one of the most explosive growth sectors in the world right now, and that is India's booming solar industry. But in today's explainer, we're going to look at it a little differently. We aren't just talking about shiny panels on a roof. We're diving into solar as a massive, complex, and highly orchestrated infrastructure operation. Think about it. When you see a solar panel, you probably think of the manufacturer who built it, or maybe the homeowner who bought it. But who actually builds the power plant? Who connects the factory that makes the panel to the electricity grid that powers your home? Well, think of these companies as the conductors of a massive technical orchestra. You know, they don't make the instruments, and they certainly aren't sitting in the audience. But without them, there's absolutely no music. So here is our agenda for today. 1. Demystifying India's solar boom. 2. How solar electricity works. 3. Inside a solar EPC. 4. The project execution lifecycle. And 5. Scaling the solar future. All right, Section 1, Demystifying India's solar boom. Beyond the panels. So India's energy demand is literally going through the roof right now. And it's being driven by rapid industrialization, massive population growth, and some pretty ambitious climate goals. To meet this incredible need for local infrastructure, we rely on the unsung hero of this boom, the EPC. That stands for Engineering, Procurement, and Construction. See, manufacturers build the products and customers consume the electricity. But EPC companies, they are the essential bridge between those two worlds. They design the systems, procure the equipment, coordinate all those tricky government approvals, and actually install the project. Basically, for the customer, the EPC is the single face of their entire solar journey. Moving right along to Section 2, How Solar Electricity Works. The Science of Solar. Okay, before we can really understand the business side of an EPC, we need a super quick primer on the science of the product itself, the electricity. It actually follows a beautiful, simple path. Step 1, sunlight strikes the semiconductor material in the photovoltaic or PV cells. This knocks electrons loose and creates an electrical current. Step 2, this generates direct current or DC electricity. But here's the catch. Your home appliances, they run on alternating current, or AC. So the absolute crucial point is Step 3, the inverter. The inverter is essentially the brain of the whole system, safely converting that DC power into AC power. And finally, Step 4, that AC power runs your appliances, and any excess energy gets exported back to the grid, tracked by a bidirectional net meter. Let's ground this science in a real-world scenario. Imagine a family that consumes an average of 550 kilowatt hours a month, which leaves them with a pretty painful 8,000 rupee electricity bill. An EPC will come in, study their consumption, survey their roof, and might recommend a 5 kilowatt residential rooftop system. So during the day, sunlight powers the house, and any extra power goes straight to the grid, literally spinning that meter backward. It's just a perfect alignment of physics solving a very real financial problem. Section 3, Inside a Solar EPC. The anatomy of the business. Now it's time to zoom out from that single residential house and look at the massive operational scope an EPC actually manages. Because, as you can probably guess, not all solar installations are created equal. An EPC has to be incredibly adaptable. On one end, you've got residential rooftop systems, typically 1 to 10 kilowatts. These require really fast execution and a ton of customer interaction. Then you step up to commercial and industrial rooftops, 10 to over 100 kilowatts. This is super engineering heavy. You're suddenly dealing with factory production schedules and heavy roof loading. And finally, you have ground-mounted solar. These are massive, utility-scale projects that are incredibly land and civil infrastructure intensive. An EPC basically shifts its operational gears entirely depending on the scale of the job. To pull all of that off, an EPC relies on an absolute army of synchronized departments. The customer only sees one unified company, but behind the scenes, it's a highly complex engine. You've got sales bringing in the leads, feeding into design and engineering, who create the technical layouts. Then procurement hunts down the best components while the warehouse manages the physical inventory. At the exact same time, project management is scheduling the chaos for the installation team up on the roof. And holding the whole shebang together, finance, handling the cash flow, and customer support managing those long-term warranties. Delivering even a single project requires every one of these gears turning together under strict standard operating procedures. Section 4, the project execution lifecycle, from build to commissioning. Let's trace the chronological heartbeat of the business to see how a project actually comes to life. We'll use a 100 kilowatt commercial factory project as our case study here.
Long before a single panel is ever ordered, the EPC conducts a rigorous site survey. And they aren't just looking at where the sun shines. They're checking the structural loading of the factory roof, examining the transformer capacity, analyzing shading. It's thorough. Only after gathering all this intelligence do they build a highly detailed bill of quantities, or BOQ, which lists every single nut, bolt, cable, and panel required for the job.
Next comes the regulatory workflow. And honestly, a major, often invisible part of the life cycle is securing government approval. You start with the customer application, which is followed by technical feasibility approval from the local DISCOM. That's the distribution company. After the physical installation is totally done, the DISCOM has to officially inspect the site for electrical safety before they finally authorize the net meter activation. Navigating this web of bureaucracy seamlessly is just as important to an EPC success as the physical wiring on the roof. Meanwhile, up on the roof, the physical installation is following a very strict sequence. First, the structural mounting goes up, and remember, it has to withstand high winds. Second, the modules are mounted. Third, the DC and AC cabling is routed. Fourth, earthing and lightning protection are installed to keep absolutely everyone safe. And fifth, rigorous system testing. Because poor quality control here, like, say, a badly crimped electrical connector, can lead to system failure or even a fire. Safety and quality are paramount.
But wait, the EPC's job doesn't just magically end when the lights turn on. Long-term solar performance will degrade if dust settles on the panels or if a component faults out. That is exactly where operations and maintenance, or O&M, comes in. Modern inverters actually allow EPCs to remotely monitor system health. Offering annual maintenance contracts, or AMCs, is absolutely vital. It ensures long-term customer satisfaction and, as a bonus, provides the EPC with a really reliable source of recurring revenue.
Finally, Section 5, Scaling the Solar Future. The digital transformation. So we've seen how remarkably complex this business is. The big question is, how on earth do EPCs scale up to handle hundreds or thousands of projects without dropping the ball? The answer is digital transformation. Running a business the old way means relying on scattered Excel sheets, searching through endless WhatsApp threads just to find site photos, dealing with manual data entry, and losing important PDF approvals. It is, frankly, pure chaos. The new way relies on an integrated enterprise resource planning system, or ERP. This essentially acts as a central nervous system, connecting sales, engineering, inventory, and finance all into one hub. A specialized digital system like Surya Hub, for example, creates a single source of truth for the company. It brings in automated workflows. So when engineering approves a BOQ, procurement instantly sees exactly what to order, which prevents costly inventory shortages. It allows for real-time project milestone tracking and heavily reduces duplicate data entry. Actually, most importantly for survival, it allows finance to accurately track profitability and cash flow on every single project. It all really boils down to this. A successful solar EPC is not just an installation company. It combines technical expertise, project management, procurement, finance, and customer service into a single coordinated business process. Having the right organizational structure and digital tools is just as critical as having the right solar panels. I want to leave you with a final provocative thought. As global solar demand just explodes and the market gets infinitely more competitive, ask yourself, is the business running on just raw energy and effort, or is it powered by integrated intelligence? Embracing digital transformation isn't just a nice upgrade anymore. It's the ultimate key to surviving and scaling in our green tech future. Thank you so much for joining me on this explainer, and keep exploring.